Now let's look at our bivariate relationships. Now we're going to be using correlations here because we have numeric by numeric pairs. So in other words, all of the variables that we need to look at our bivariates are all numeric. Just as a reminder, Pearson's R ranges from -1 to +1, where in absolute value terms, a score of 1, so be it negative or positive, a score of 1 is a perfect correlation, a score of 0 means there's no correlation at all. Now, we do have a null hypothesis for Pearson's R, and the null hypothesis is that your Pearson's R is 0. So we went over this syntax last week, but just as a reminder, pwcore is our command. Then we have all of our variables listed. Correlation doesn't distinguish IVs from DVs, it just has variables. As good practice, I would put your DV first. That way, when you look down the first column, it's the relationship between your DV and IVs. But really, it's up to you what you do here. We do need the subcommands sig and obs. Sig gives us our p-value and obs gives us our observation number, which is important in case we have missing data. So here is our correlation output, and we can see ratings in the first column, and then we can see our 3 IVs. So if we go down this first column, what we notice is that there is a significant positive, strong, let's try that again, moderate relationship between ratings and research. If we look at build, there is a weak relationship between, and it's positive, between build and ratings, but it's non-significant. Our p-value is above 0.05. So despite the fact that generally speaking, as ratings go up, so does the time the student spent building the project, it's not actually a significant predictor of ratings. If we look at ratings and how innovative the project is, we see that there is another moderate, significant, and positive relationship. If we look at our ends, our observations, we can see that there's 24 observations in every single test, telling us that there's no missing data. We can also look at the correlations between our IVs if we were interested in this. It's not too important for what we're doing today, but we will look at this next week. So now we can look at our scatter plots. We'll look at just one, so we'll look at ratings and research. But what we're about to do, you can apply to the other two if you wanted as well. And I strongly recommend that you do so. So just as a reminder, the syntax to produce your scatter plot is two-way and scatter as two separate words. Then your, as good practice, do your DV and then your IV. So ratings and then research. Oh, sorry, rating. And then research. And then we need to do the same thing. So we have two vertical lines, and then we type in lfit dv iv again, and it has to be the same dv and iv that you had over here. If you don't do this, it'll fit a different line. So if you put a different set of variables here, it'll fit the line of best fit for those variables rather than what's in your scatter. So here I have the 7 different features of a scatter plot, and you should comment on these whenever you have a scatter plot. So let's look at the first, direction. Is it positive, negative, or is there no direction? Looking at the relationship, I can see hours of researching down here, and then the judges' scores goes up the side here on my y-axis. And what I notice is that as hours of researching increase, so does the judges' score. So there is a positive relationship here. And this was reflected in our correlation matrix. The next question is whether or not our scatter plot demonstrates a monotonic function. So remember that a monotonic function simply means that all of my dots go in one direction. They might change in magnitude. So it might be a curvy line, but it's always going up or it's always going down. Here I can see that my points, generally speaking, the cloud is always going up. It doesn't sort of bend and then start coming back down. So it's monotonic. The next question is whether or not it's linear. So linear is asking, okay, we know that it's monotonic, we know that it's always going in one direction, but does it consistently go in that one direction to the same magnitude? In other words, if I put a line of best fit through my the cloud of points, does it actually fit basically through the middle of my cloud of points? Or is my cloud of points sort of starting to go up in this direction? And what I see is, generally speaking, this looks perfectly fine. Like, I know looking at these points here, it looks like the data is starting to swing up, but really if I hit that point there, what we notice is that it's basically a linear relationship. This point just seems to be a little bit high. So I'd say that we have a linear relationship here. Just as a reminder, if you have a linear relationship, by definition, you also have a monotonic relationship. But just because you have a monotonic relationship does not mean you have a linear one. Okay. Next question is strength. Is it weak, moderate, or strong? To me, this looks like it's moderate. I'm making this assessment because the line is relatively steep and the dots are pretty close to that line. We use our correlations to confer the strength. So if we go back to our correlation matrix, we can see the relationship between ratings and research is just above that 0.5. Do we have any outliers? Not really. That point is a little bit above the others, and this point's a little bit below, but they're not extreme. They're not changing that line in any way. They don't really seem to be influencing it. Honestly, I would say that there are no outliers in this. This looks perfectly fine. Finally, are there any gaps? There aren't any gaps. I have a single cloud of points. If I did have gaps, I'd have multiple clouds of points, but I've only got the one. So this is fine. I would now go ahead, if you have the time, and go to the other two on your own, following the same process that I did and describing it in those 7 features.